Let me push it again. Okay, so the first one, how you want to draw? Okay, so you have to know that mirror use the reflection, right? So the reflection, so first one, okay, the light ray come from, okay, from here, okay, from here goes to here, okay, and then it will reflect back to the focal point, okay, right, and then the next one from here go to F, okay, and then draw the line back here, okay, so it will reflect back, okay. Okay, so this is the first ray diagram, right? So this one when the U is equals to F, okay? So means the object is at C here, okay? The object is at C here because C is actually equals to F, okay? Okay, so now you have to state the characteristic of image form. Okay, for the mirror, if the mirror, if the image form behind the mirror, so this one should be virtual. Okay, and this one should be real. Okay, so since the image is formed in front of the mirror here, so the first characteristic is real. Okay, so this is the image, right? This one. So real. Okay, and then this one whether it's upright or inverted, right? So this one should be inverted. Okay, inverted and also same size. Okay, same size as object. Okay, so this is the when the object is at C or when the object is at 2F. Okay, this is the object. Okay. We can try to draw. Right. Okay, so the next one, okay, so the next one, wait, I push to over here. So the next one is when the U is at the position between F and 2F. Okay, so between in the middle here, okay, between F and 2F. Okay. So same way as you draw the first one, okay. So the first line, okay, the first come from the arrow here, okay, and it go here, and then reflect back at the focal point, okay, and then the second one goes to F and reflect back. Okay, so this one also should be same. Okay, so can you try to draw it first? And try to see the characteristic of the image. Okay, good. Real, inverted, magnify, correct. Which real, okay, real, inverted, magnify, upright, diminish. Yuan, okay, Yuan, this one you draw the light ray and pass through the center of um, the mirror, right? Actually, this one is for lens. For mirror, you don't, you can draw like this. Okay, you have to reflect it back. Okay, so this one you can erase it back and try to draw it again. Let's see the lens. Okay, so let's see how you draw it. Okay, the first one, okay, from here goes to here and reflect back to F. Okay, right. The second one goes here, okay, and then straight line like this. Okay, so this is the image. Okay, so you already know if the image form in front of the mirror should be real, right? And if behind the mirror should be virtual, right? It's opposite than the lens, right? So if the lens form in front of the mirror should be virtual, okay, if behind the mirror should be real. Okay, so it's opposite between lens and mirror. So this one should be real, okay, and then still inverted. Okay, and the last one should be magnified. Or you can say bigger than the object. Okay, this is for case number 3. Okay, if the object is between F and to F. Okay, before this the first one is at 2F here. Okay, and this one between F and to F. Okay, so the next one should be, okay, case number 4 is when U is actually equals to F. Okay, so when the object is at the focal point here. So how you want to draw? Okay, so wait, I push the. Okay, try to draw it first. Okay, okay, try to draw it. Focus. I will try to push it. Okay, good. Okay, it will reflect it to F. Okay, good, Jayun. Okay, Hmm. Okay. Some of you got it correct. Okay, and then put the characteristic of the object. Okay, some of you already know. Okay, so the F will, the light ray will, the ray will go here and then will reflect back to F, right? And then the second line should be goes to F and reflect it back, right? But since there is no F in front of it, so how you want to draw the second one? Okay, the second ray diagram. I is at infinity, form at infinity, correct? Hmm. Yo, yo, okay. Okay, so let's see how you want to draw, right? The first one, okay, draw from here, okay, go back to F, right? Because mirror use reflection. Okay, and then the second one, because when you see the first ray diagram that we draw, right? So the ray should be go to F and reflect it back, right? But since there is no F in front of the object, right? There is no focal point in front of the object. So what you can do, okay, you can do from C here, okay? From C here, pass through the head of the arrow here, okay? And then you make it longer like that, okay? Right? So you can see here the image, right? And then you try to make it the line longer. Okay, you can see there is no image will be formed. There is no intersection, right, between the two line length, right? So there is no intersection, but you know that the image will form at infinity. Means we don't know where is it. Okay, image at infinity. Okay, but other than that, right, we know that if you make it a line longer, so the image will form in on this side, right? So on this side should be visual, okay, visual, okay, and then should be image should be magnified, right? So should be magnified, okay, magnified, and also should be upright, okay. Even it at infinity, okay, we already know that if you make it longer, so the image will form on this side. So the on this side, so if in on this side should be visual, okay, and then should be upright, right? If inverted should be down here, right? So if image form up here should be upright, and also the image will be magnified. Okay, other than we know that is formed at infinity. Okay. So I hope you are clear for this one if U is equals to F. Okay. Alright, so the next one is when U is bigger than 2F. Okay, when U is bigger than 2F means the object is larger than 2F. So this one is 2F already, right? So the image, the object will be here. Okay, so if 2F is here, so bigger than 2F should be here. Okay, I push the to okay, so this one you can draw like this one. The ray diagram is same like this one because this one also the no, this one you can draw like the first one. Okay, like the first one because there is F right before the object there. Okay, so F is here. So you can like this and then like that. Okay, and then try to put the characteristic of the image. Okay, good. Below inverted diminish. Okay, sure, wait. Real inverted diminish. Good. Okay. So most of you got it correct. Real inverted diminish. RID. Okay. So from here, okay, from here goes to here. Okay, reflect back to F, A, and then from here goes to F, A, and reflect back. Okay, so the image will be here. Okay. Alright. Okay, and then the characteristic should be, okay, so real, okay, still inverted. Okay, and then the last one should be the size of the image should be smaller than object. We can call it diminished. Okay, so this is when the object is bigger than 2f. Okay. 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 Alright. So this is the and then okay, we see the next one. Okay, when the u is smaller than f. Okay, so mean before f, right? So this one you have to draw. Wait, I push the background first. Okay, so for this one is same like this one. Okay, so this one is same like this one. Okay, u equals to f and u before f, right? The object is before f or the object is at f. Okay, so we have to draw like this. Danisha, the image there will be image forms. I mean there should be intersection between the two two line of the ray light. There will be an intersection. See where you draw it wrongly. Virtual, upright, and magnified. Okay, correct. Virtual, upright, and virtual, upright, magnified. Okay, good, Trija. Given, good. Join, Alvan, Yanzi, Kelly, Living, Hey Jayun, Beijing, Hoyi, Vicky, Mandy, Vincent, Viren. This one is Sue, right? Sue, Sinju, Sujin, Keijenzi, Yinhui, Yunxiang, Junkong, Yuan and Alvina, Jinyo, Yuchi. Okay, we got it correct. Okay, so let's see how we want to draw it. Okay, so the first one should be from here. Okay, and reflect back to F. Okay, and then the second one should be from C. Okay, pass through the head of the arrow here. Okay, and then make it longer. Okay, until it's intersect. Okay, so the image should be here. Okay, so the image should be here. Okay, so you can see the image is formed behind the mirror, right? So means it should be virtual. Okay, virtual. And you can see the size of image is bigger than the size of object. So this one should be magnified. And also the last one should be upright. Okay, because it's like this. If inverted, it should be down like this. Okay, right. So the last one. Okay, so we already see the 5 cases, right? The five conditions. Okay, when the object is at F, before F, right? At between F and 2F, at 2F or bigger than 2F. Okay, for concave mirror. Okay, let's see for the convex mirror. Okay, for the convex mirror, there is only one way for you to draw the ray diagram. Okay, so there is only one way for you to draw. So it doesn't matter where the object is. Okay, the way to draw it is only like that, and also the characteristic is only that one. Okay, it's different from the lens, right? So for the lens, the convex lens has many way to draw. It's according it's depend on the situation. It's depend on the position of the object, right? But for the concave lens, only one diagram, right? Only one way to draw, and that's only the one characteristic. Okay, so wherever the object is, the way you draw is same, and also the characteristic is also same. So it's opposite. Okay, so you have to remember for the convex lens, for the lens, the convex lens, they have many ray diagram. It's depend on the object. Okay, where's the object is. Okay, but for the concave lens, only one way to draw. It doesn't matter where the object is. Okay, for the mirror, okay, it's opposite. For the concave mirror, you have to depend on the object, right? Where's the object is. Okay, but for the convex mirror, only one way to draw. Okay, so we see how to draw for the convex mirror. Okay, this one is actually convex, right? So just ignore the label here. This one should be convex, not concave. Okay, concave should be like this, right? Concave should be like that. So this one is actually convex. Okay. Okay, for the convex, okay, so I give you a clue, you should add one more here. Okay? C here. If you want to be able to draw, you have to add C here. Actually, there are three light ray that you can use, right? But for me, I'm using two. Okay, you can use two or you can use three also. It doesn't matter. The image form will be same, right? But for me, I only use two. Okay, so you can add C there. If you want to get the image, so you have to have C there. Okay, good, Jiwon, Shija, Alvin. Okay, for convex, the way to draw is not same as concave, right? I know concave you draw from here and then you go back to F, right? And then the way to draw for convex and concave pen is not same. Okay. You can see some of your friends, like Elvin also is correct, Jiwon also correct, Shuja, okay. Maybe you can see their answer, okay, as a reference. for you to draw jumping. This one is not correct. This one is for concave only. For convex, you cannot draw like this. Giant, this one is for lens, right? So this one is not convex lens, okay? This one is wrong. Jing, correct. Jingwei, wrong. Oyi, correct. Inkian, okay, correct. Niqian, okay. Yuren, right, good. So you should label the image. Where is the image? You should label the image here. Put arrow there. Yanling. No, this is not. This is for lens. Okay. For lens, yes, you draw like this. For convex lens. Okay. This one is mirror. Mirror, you have to use reflection. So whatever it is, you must have the reflection ray there. Okay, so if you draw like this one is actually refraction, right? If the line pass through the lens, right? So means that one is refraction. So you can see for what we draw here for the concave lens, all is reflected back, right? So because concave mirror, all will reflected back, right? Because I already told you mirror use reflection. So same also like convex mirror, you have to use the reflection. Cannot use you cannot use same as the convex lens. Okay, it's wrong. Okay, it's okay. At least we know that we learn something already, right? Before this, I just stopped on my own. I don't know whether you understand or not. So now I know that some of you still cannot draw the diagram ray for the mirror for the concave. Okay, so let's see the convex mirror. Okay, so the convex mirror should be from here. Okay, from here goes here. Okay, and we go to F. Right, and then it will reflect it back. So actually, the light ray goes here and reflected back. Okay, and then you just make it longer. Okay, from there. Okay, and then the second one, that's why I say you have to put the C here. Okay, so for this one, here goes to F. Okay, and then the image should be here. Okay, so this one is actually like that. So it still reflect. Okay, it will still be reflect by the mirror. Okay, and then this one is like the imaginary, right? Imaginary lines to show where the image is. Okay, because if you draw like this, like only you draw the reflection ray, right? You can see there is no image form. Okay, so that's why you have to make it longer. Okay, and it goes until C here. So this one should be the image. Okay, so what is the characteristic here? So this one, the first one should be visual, okay, upright, and diminish. Okay, alright, so this one is for convex. So let's say the object is at F. Okay, so the way you draw still be same and you still get the same characteristic. Okay, even that you put it at F or before F, okay, the same characteristic. Okay, you have the same characteristic and also the way to draw is same. Okay, so means the convex mirror only have one ray diagram. Okay, compared to the concave mirror. Okay, so I hope you remember about that. Right, so I hope you are clear how actually you want to draw the convex mirror. Okay, so remember mirror must use reflection. So whatever you draw, you have to show the light being reflected. Okay, for lens, you have to show there be a refraction. So whatever you draw, you have to show the refraction ray. Okay. Right. So let's see for the question. Okay. So we already learned how to draw this one. Okay. So the application of the mirror. So what's the application for the mirror? Right. For the plane mirror, so it will be used in the optical testing. Okay. Mirror in ammeter or voltmeter. Right. So if you see the voltmeter and ammeter, there will be like a mirror, right, below the reading there. So that one is actually to avoid the parallax error. So when you see when you read the voltmeter, you have to make sure that the image of the pointer is actually uh, below the pointer. I mean, it will be intersect. Okay, so this one to avoid parallax error, make sure the image of the pointer directly below the pointer itself. Okay, and it will be used in periscope and also kaleidoscope. Periscope is actually plane mirror used um, for total internal reflection, right? Okay, and convex mirror. Okay, this one is we use it as a because it has a wider field of vision. Okay, as an example, side mirror of the car, right? Surveillance mirror, blind corner mirror. Okay, and for C concave mirror, so this one we want to have because we want the image to be larger than the object. Okay, so the example is a shaving mirror, dentist mirror, right? Makeup mirror, and also a bicycle head lamp. So because we put it at the at F, right? So at F because we want to produce the parallel beam of light. Okay, so this is the application of mirror that you have to know. Okay, all right. So let's see the question. So the first question number 23, right? Which of the following ray diagram shows the correct reflection of light from a curved mirror? So curved mirror, whether it's a convex or concave, right? So you have to know that the convex mirror is actually convex mirror is actually the divergence mirror, right? So mean the light ray will be diverged. Okay, but for the concave mirror, it should be convex mirror. Okay, known as a convex mirror. Okay, but because sometimes the question doesn't give you the type of the mirror. Okay, they just said whether it's a converging mirror or diverging mirror. Okay, so this one, if you can see, this is the convex. Okay, convex should be divergent. So this one is convex, right? So this one is wrong. Okay, for B, this one is a concave, right? So concave should be converged. So this one is diverged. So this one also wrong. Okay, so this one is a concave, right? And also it converged, right? So the light ray is converged at one point that we call it as F here. Okay, so number 23 is C. Okay, number 23 is C. Okay, the next one, okay, so the telescope. Okay, so telescope. So the astronomical telescope consists of two two diverging lens, right? Two diverging lens. Okay, because they use the convex mirror. Okay, so remember for telescope and microscope, both of it use convex mirror. Okay, sorry, convex lens. Sorry, this one is converging lens. This is lens, not mirror. Okay, so use the converging lens because convex is a converging lens. It's opposite than mirror, right? Okay, for lens, concave lens is diverging lens. Okay, and for convex lens is converging lens. Okay, so it's opposite the mirror. So the astronomical telescope consists two converging lens. Okay, so the objective lens has a focal length FO and the eye lens has a focal length FE. So the first one, let me introduce first, right? So this is called as the objective lens. Okay, so this is called the objective lens. You can see the diameter of the objective lens is bigger than the eyepiece lens. Okay, so this one, why you must have the big diameter. This one is to allow the more light ray to enter. Okay, all right. So and then this is called as objective lens. This one is called as the eyepiece lens. Okay. So the distance between F, okay, F and also the here, okay, this is called as FO, the focal length of the objective lens. Okay, FO. Okay, O is actually for objective, E is actually for eyepiece. Okay, so this is called as FO. Okay, and then from F here to the center of the mirror of the lens here, okay, this is called as FE. Right? So the objective lens has the focal length FO and the eyes length as focal length FE, where FO is bigger than FE. You can see the length of the FO is bigger than FE. Okay, but sometimes when you mix up with the microscope, right, you will be confused, correct? Which one is FO is bigger than FE, which one is FE is bigger than FO. Okay, for me, this is astronomical telescope, right? So you can count. This one has 1, 1, 2, 3 O, right? Okay, and then for the microscope, okay, for the microscope, okay, this one only got 2 O. Okay, so this one got 3 O, this one got 2 O. So this one has many O than this one, right? So this one should be FO is bigger than FE. So that is the way maybe can help you to remember, right? To memorize which one is FO, which one is FO is bigger than FE, which one is FE is bigger than FO. Okay, for astronomical telescope, you just compare. I just count how many O. So let's say astronomical telescope got 3 O and microscope only got 2 O. So means astronomical telescope has many O than microscope. So FO is bigger than FE to astronomical telescope. Okay, so that's the way if you want to memorize. Okay, so FO is bigger than FE. And so the lens also for the objective lens here, okay, the power is lower, okay, compared to the eyepiece here. Okay, and you also can see the image form is at the focal point of FO and FE. Okay, alright. So this is how you want to draw the ray diagram for the astronomical telescope. Right. So the next one, okay, the characteristic image formed by an astronomical telescope. So the first image. Okay, so the first image, okay, you know that actually the telescope we used to see the star, right? The moon, right? The object that is actually far away. Okay, so this one, okay, so the object comes from the far away object, and then this is the first image. Okay, this is the first image. And then the first image will become the object for the eyepiece, right? The first image here will become the object as a for the eyepiece here. Okay, and then the last image should be here. Okay, so the last image is actually at infinity. Okay, so I hope you remember. So the first one, the object come from the, let's say from the star, right? You want to see a star, a moon, okay, a planet or something. Okay, and then they will form the first image here, right? At FO, okay, or at FE, okay. And then the first, the image from the that form here will become the object for the eyepiece here. And then it will produce the second image, okay, that is actually at infinity. Okay, so means there is two image form for the telescope. Okay, the first image from the first lens for the object from the objective lens. So when the image, when the light ray pass through the objective lens, it will form the first image, and this first image will become the object for the eyepiece and produce the second image. Okay, all right. We see the characteristic of the first image. Okay, so the first image you can see it be formed behind the lens. So behind the lens should be real, correct? Because if mirror, we learned before, if behind the mirror is virtual, okay? but for the lens, it's different. Okay, so this should be real. Okay, and it's inverted. Okay, and smaller than object. Okay, so let's see whether it's correct. Okay, see, okay, real, okay, inverted and diminished means smaller than object. Okay, so this is the first image. Okay, the characteristic for the first image here. Okay, and then the first image will become the object for the eyepiece, right? Okay, then the eyepiece will produce the second image, or we call it as the final image. Okay, so the final image, okay, so the final image should be at infinity. Okay, at infinity, but we know the image is produced in front of the eyepiece, right? The image is produced in front of the eyepiece, just we don't know where. Okay, so maybe somewhere here or what. Okay, so in front means should be visual, okay, visual, okay, and also magnify. Okay, and this one should be inverted. Okay, visual, inverted, and magnify. Okay, visual because it produced in front of the eyepiece lens. Okay, this one because it produced behind the objective lens. Okay, behind is real. This one because this one it become the object already, right? So it formed in front of the mirror, in front of the lens. So should be visual. Okay, visual, magnified. Okay, and also because it come to the light ray will become below here, right? So should be inverted. Okay, so I hope you understand. Okay, so the final image located is at infinity. Okay, at infinity. Okay, and then the next one is how you want to find the magnifying power. Okay, so the magnifying power, okay, we use the formula FO divided by FE. So let's say the example I give here, right? So let's say the FO here, the length between the center of the lens here to the FO here, let's say is 20. Okay? And then FE here is from the F focal length of eyepiece here, goes to the center of the eyepiece here, let's say it's 5 cm. So how you want to count it? So you just divide. FO is 20, right? And FE is 5. So you got 4, okay? So there's no unit for magnifying power, okay? Because this one is cm, this one is m, then you cut it, you just can have the unit. So actually the magnifying should be 4. Okay, so I hope you understand. Okay, so let's see the next question. So the focal length of the objective lens of astronomical telescope is 100 cm. So the magnification of the telescope is 20 cm. So what is the focal length of the eyepiece? Okay, so M is FO divided by FE. The M is already given. M is 20. Okay, FO is actually 100. FE is you need to find. Okay, so you got 5. Okay, so you got 5 cm. Okay, so that's how you want to answer for this question. Okay, let's go to the next one. Okay, microscope. Okay, so microscope, a compound microscope consists of two converging lenses. So remember, microscope, telescope both use convex lens. Okay, there is no concave mirror using. Okay, so converging lens, so the focal length of the eye lens is long and the focal length of the objective lens is short. Okay, means FE is long, FO is short. So mean for this one is FE is bigger than FO. So it's opposite than the telescope, right? Telescope, FO is bigger than FE. For microscope, FE is bigger than FO. Okay, so let's see the diagram. Right, so FE is bigger than FO. So you can see this one is FE, right? Okay, and this one is FO. So you can see the length of the focal length, focal objective for a focal length of the FE is bigger than FE. Okay, so this is FO, this is FE. Okay, FE is bigger than FO. Okay, so I hope you can understand the difference between microscope and telescope. Alright, okay. The next one is, it say here the objective lens is arranged such that the object distance is, the object distance U is between FO and 2FO. So means the object should be, okay, should be between F and 2F. Okay, so this one you have to remember. Okay, for the telescope, you don't have the object distance. Okay, but for the microscope, you have the object distance that must be between F and 2F. Okay, alright. And then the next one, okay, the eye lens is used as the magnifying, okay, lens. Okay, the eye lens is means this one. Okay, same like before. The first lens here we call it as objective lens. The second one is called as eyepiece lens. So this eyepiece lens, okay, will act as the magnifying lens. Okay. Alright, and then the total length S between both lenses is S is bigger than FO plus FE, or sometimes they use L. L is FO bigger than FO plus FE. Okay, like this one. Okay. Okay, what does it mean by L is bigger than FO plus FE? Okay, L is actually from here to here. Okay, from here to here. This is called L. Okay, and this is FO, length of FO. This one is length of FE. Okay, so let's say I have this one is 5 cm, this one is 10 cm. So means the FO plus FE is 15 cm, right? But for L, you can see there is still a gap here, right? For L is from here to here, right? So means that you can see there is still a gap here. So it must be any value here. So let's say 3 cm, right? So mean L is actually 5 plus 3 plus 5 plus 3 plus 10, right? So you've got 18. So you can see actually L is bigger than 50 cm. Okay, L is actually from here, the center of the objective lens, to the center of the eyepiece lens. Okay, this is called as L. Okay, FO is from here to here and FE is from here to here. Okay, then you can see there is still a gap. If you want to count the L, there is still a gap here that you need to count, right? So that means L is bigger than FO plus FE. Okay, alright. Okay, so let's see the characteristic of the image first. So let's say this is the object. Okay, so when the object passes through the lens here, it will form the image, the first image. Okay, and then this first image will become the object for the second lens, that is eyepiece. Okay, so let's see the first image first. So the first image first, this one is formed behind the mirror, so should be visual, right? Visual, okay, and then should be inverted. And you can see the size of image here is bigger than object, so should be magnified. Okay, so this is the characteristic of the first image. Okay, and then the second image is form. Okay, visual, real, real, not visual. Visual is actually from here, right? Real. Okay, and then the second one, this first image will become the image for the eyepiece lens. Okay, so this one should be visual. Okay, visual, because it produced in front of the lens. Okay, so visual, inverted, and also magnified, right? So this is the image, the last image, the final image. So the final image should be visual, inverted, and magnified. The first image is real, inverted, and magnified. Okay. So let's see the last question before I stop. So what are the required conditions for the lens of the focal length f to be used an objective lens for a microscope? Okay, so remember all the microscope and telescope they use a convex lens, so this one should be wrong. Okay, and then the object distance for the microscope should be between f and to f. So the answer should be B here. Okay. Right, for the telescope, there is no object distance, okay, because the object is very far, right? Okay, so I think that's all for today, okay? So thank you, class. So I will continue class during the school holiday at Wednesday, 9 a.m. Okay, all right, thank you, class.